Let us define the x-center of a triangle. We'll begin by considering a triangle ABC. So here we're considering a scalene triangle. Now let the coordinates of each of the vertices be given by x1, y1. The coordinates of B, that will be x2, y2. And coordinates of C, that is going to be x3, y3. Now, we have already defined the incenter of a triangle. Incenter means the three angle bisectors of the triangle ABC meet at a common point, and that point lies inside the circle, and that's going to be defined as the incenter of a triangle. However, to define the excenter of a triangle, we still need the three angle bisector, but in this particular case, one of the angle bisector will be internal and two of them will be external, meaning to understand this problem, what we'll do, we're going to extend the side AB of the triangle, and we are also going to extend the side AC of the triangle. So let's do that. So here we have extended the side AB of the triangle. Let's say AB gets extended to B prime and AC is extended to C prime. So we have AC prime. Now what we'll do, we are going to bisect the angle A, angle B and angle C, and there is going to be a common point where these three angle bisectors are going to intersect. So as we can observe here that the three angle bisectors meet at a common point, and that's going to be defined as the x-center of the triangle. And we can see here that the x-center lies outside the triangle. And we have already defined the incenter of the triangle, so we're going to denote the incenter by the point O. This is the point where the three internal bisectors of the triangle ABC meet. And our goal will be to obtain the coordinates of the x-center I prime. Now what we'll do, in our case, we're going to use the information that we already used while finding out the coordinates of the incenter. Okay, you can check out that video. I'll put a link on the description here. So let's say we have the triangle ABC. Here we are going to name the sides of the triangle. The side BC, this is the side that's opposite to angle A. So we're going to denote it by the letter A in lowercase. Then we have side CA. This is the side opposite to angle B. So we're going to denote it by the letter B in lowercase. And finally, we have AB. So we're going to denote it by the letter C in lowercase. So we have all the three sides. We have this particular point D where such that AD bisects the angle BAC. Since AD bisects the angle BAC, so we can say that AD divides the line BC internally in the ratio C is to B. We've already defined it, so let's write it down as well. So we have BD over DC. This is going to be C over B. Now since this is an internal division, so what we can do, we can use the section formula. So using the section formula, we can define the coordinate of D. So the coordinate of D, that's going to be, so we'll start with B. We'll have B multiplied to the x coordinate of B. So that's going to be x2. Added to C times the x coordinate of C. So that's going to be x3 divided by B plus C. Similarly, we can define the y coordinate. So we'll start with B and multiply it with the y coordinate of B. So that's y2 added to C times the y coordinate of C. So that's y3. So by2 plus cy3 divided by B plus C. So this is going to be the coordinate of point D. Fine. And we also found out the ratio in which the point I or the incenter divides the line AD. So we found out that is B plus C and A. I is dividing the incenter of the triangle divides AD in the ratio B plus C over A. So let's write that information as well. So I have AI over ID. So this is going to be equals to B plus C over A. Now it turns out that I prime is, since I prime lies on the line AD, on the extension of the line AD, we can clearly say that I prime is the harmonic conjugate. It's going to be the harmonic conjugate of I. That means that if I divides AD in the ratio B plus C over A internally, then I prime is also going to divide the line AD in the ratio B plus C over A, but externally. That's what it means, that I prime is the harmonic conjugate of I. We can say that I prime divides AD externally. It's going to divide it externally in the ratio B plus C to A. Now what we can do, we can apply the external section formula. So let's try to find out the coordinates of I prime. So here we are considering this line AA prime. So this is the endpoint A, the other endpoint will be denoted by I prime. So here we have the incenter I and then we have D. We have already defined that the incenter I, divides AD into ratio B plus C and A. And we have mentioned here that I prime is going to divide AD into ratio B plus C and A, but it is going to divide it externally. So that means we have to use the external section formula, which means that coordinates of I prime, that's going to be equals to, so here the x coordinate will be, so we'll start with, let's say A. So A will be multiplied to the x coordinate of A. So here x coordinate of A, that's x1. So we have A times x1. But this time we'll have to consider minus. So we have minus of B plus C multiplied to the x coordinate of D. So the x coordinate of D, so it's simple. So this is going to get multiplied with this, and A is going to get multiplied with A. So B plus C times the x coordinate of D, so that's bx2 plus cx3 divided by B plus C. Fine. Whole divided by, we have A minus B plus C. Then let's find out the y coordinate. So the y coordinate is going to be, so we take A times, so we'll multiply A with the y coordinate of A, so that's y1, minus B plus C multiplied to, then we have the y coordinate of D, so that's going to be by2 plus cy3 divided by B plus C, whole divided by A minus B plus C. Fine. So this is I prime. Okay, so let's further simplify. So here we can cancel out B plus C as well as from the x and the y coordinate. So we will now get I prime. So that's going to be AX1 minus of BX2 plus CX3 divided by A minus B plus C. And the y coordinate is going to be AY1 minus of BY2 plus CY3 whole divided by A minus of B plus C. What we can do, we can multiply both numerator and the denominator of the x coordinate with -1, and we'll do that to the y coordinate as well. And that's going to give us the result. We have negative AX1 plus BX2 plus CX3 divided by minus A plus B plus C. And the y coordinate will be negative AY1 plus BY2 plus CY3 divided by negative A plus B plus C. So this is the coordinate of the excenter of the triangle ABC. Now the question is there only one excenter possible? The answer is no. There will be in fact two more excenter possible. So that can be obtained because the criteria was that to find out the excenter, we have to take triangle bisector. One of them is going to be internal and two are going to be external. Here we have internally bisected angle A and bisected B and angle C externally. So we will bisect angle B internally and the other two angles, angle A and angle C externally, such that we get the excenter at a point which lies outside the triangle and in front of the side AC. Similarly, we can take the internal bisector of angle C and the an external bisector of an angle A and B. That's going to give us the third excenter, which is going to lie away from AB. So let's look at the diagram as well. As you can see in the simulation, we have a triangle ABC. First, what will begin by internally bisecting angle A and externally bisecting angle B and C, and they're going to meet at a common point, and that's going to be the excenter I1. Next, what we can do, we can bisect angle B internally and angle A and C externally, and they're going to meet at the second point, and that's going to be the second excenter of the triangle. So they meet at I2. Then we finally bisect the angle A and B externally and bisect angle C internally, and it's going to meet at the third point, and this third point is going to be the third excenter of the triangle. Let's come back to the coordinate of the excenter of a triangle. Now this is the incenter of the triangle, which corresponds to, so here in this case, we have the triangle ABC. If A is bisected internally, B and C are bisected externally, then this is going to be the excenter of the triangle I prime, which lies in front of the line BC. So what about the excenter which lies in front of AC? So in that case, all we get is, let's call it this is I1 prime, then I2 prime. This is I2 prime. Then the coordinate of I2 prime will be, to remember it, so what we'll do, so this is the side B. So since it corresponds to side B, so we'll have AX1 minus BX2 plus cx3. So using the simpler method we can prove that, but there's no need because we can similarly write it down as a minus b plus c, comma, and the y coordinate will be ay1 minus cy3 divided by a minus b plus c. Now what about the third excenter I3 prime, which lies in front of the line segment AB? So since this is denoted by the side 3, so we're going to get ax1, the x coordinate will be ax1 plus bx2. This time we'll have negative cx3 divided by a plus b minus c, and the y coordinate will be ay1 plus by2 minus cy3 divided by a plus b minus c. So this is how we can define the coordinates of the three excenter of the triangle ABC.